What NDT methods reveal microscopic cracks in structures? Imagine trying to find tiny cracks in a metal piece or a concrete beam without breaking it apart. How do engineers spot problems that are too small to see with the naked? That's where non-destructive testing methods come into play. These techniques let us look inside materials and find cracks that could cause big failures later on. One of the most common ways is ultrasonic testing. Think of it like using a supersensitive echo. High-frequency sound waves are sent into the material. When these waves hit a crack or flaw, they bounce back differently than from intact areas. This helps pinpoint tiny cracks both on the surface and beneath it. Advanced versions like phased array ultrasonic testing or automated ultrasonic testing can scan large areas quickly and detect cracks as small as a few micrometers. Eddy current testing is another handy method, especially for metals. It uses electromagnetic fields to check for disruptions. When a crack is present, it changes how these currents flow. This makes it easier to find tiny surface or near-surface cracks. It's quick and sensitive, perfect for inspecting complex parts like aircraft wings or engine components. Radiographic testing, which uses X-rays or gamma rays, creates images of the inside of a structure. If a crack is very small but inside the material, it can cause density differences that appear on the image. For even more detail, computed tomography scans produce 3D images, letting us see microscopic cracks inside complex shapes without damaging the part. Magnetic particle testing is especially good for ferromagnetic materials like iron and steel. The process involves magnetizing the part and sprinkling magnetic particles on its surface. These particles gather at tiny cracks, forming visible lines that show where the flaws are. It's quick and effective for surface and slightly subsurface cracks. Acoustic emission testing listens for tiny sound waves produced when cracks grow or form. When a crack starts or spreads, it releases elastic waves that can be detected in real time. This makes it useful for ongoing monitoring of structures under stress, catching problems early before they become serious. Advanced ultrasonic techniques, called nonlinear ultrasonic methods, take detection a step further. They analyze how high-frequency waves change when they interact with microscopic cracks. These tiny cracks cause the waves to produce harmonics or subharmonics, signals that are very sensitive indicators of tiny flaws that traditional methods might miss. Often, engineers combine these methods to get the clearest picture. For example, ultrasonic testing might find a suspicious area, then magnetic particle or eddy current testing confirms if microscopic cracks are present. Continuous monitoring with acoustic emission can alert us to crack growth over time. Understanding these tiny cracks early helps prevent big failures. Detecting flaws before they grow into dangerous breaks allows for repairs or replacements, saving money and lives. These NDT methods give us a way to see what's hidden inside materials, making sure structures stay safe and reliable. In short, ultrasonic testing, eddy current testing, radiography, magnetic particle inspection, acoustic emission, and nonlinear ultrasonic techniques are all powerful tools to reveal microscopic cracks in structures. They help us investigate, diagnose, and prevent failures before they happen, keeping everything around us safer.